Binary search. Binary search is an algorithm which searches for an element in a sorted array. So let's see what steps binary search takes using an example. This is going to be my array. And these are going to be my elements. So let's say we tell the algorithm, search for 25. So what the algorithm has to do is, it has to check whether 25 exists inside the array. If it exists in the array, it has to return the index at which it was found. If it does not exist in the array, it has to return a -1, indicating that it has not been found. So the first thing the binary search algorithm will do is it's going to define the range in which it's going to search. We are searching for 25 within the entire array, so the range is going to be from 0 up till 9. The starting index at which it starts the search is going to be called start, and the ending index at which it ends the search is going to be called end. Let me write down the steps on this sheet of paper. So what is the first step? Define start and end. Let's see the second step. The second step is find the middle index. The middle index is going to equal to start plus end divided by 2. In this case, it's 0 plus 9 divided by 2, which is equal to 4.5. Now, of course, an index has to be an integer. And so, we will take the floor value of this computation. The floor value of 4.5 is going to be 4. So, our middle is going to be 4. The next step we do is, we are going to find where the element we are searching for will be placed with respect to the middle. So let's see. I have my middle element as 20. Would I expect 25 to come to the left of 20 or to the right of 20? Since it's a sorted array and it's going in ascending order, I'm going to expect the element 25 somewhere in any index which comes after 20. I know that all the indexes or all the elements that will precede 20 will definitely be smaller than 20. 25, which is greater than 20, is going to be present somewhere after the index which 20 was found at. So, we are only now interested in searching the elements which are going to appear to the right of the middle index. We know for a fact that 25 is not going to be found in any index which is going to be preceding 20. So, what have we said here? If the element found in the middle, in this case it's 20, if that is going to be less than the element we are searching for, then we have to search to the right we have to search to the right of the middle element. So now we must reduce our range of the search. So where should the search start from? The search should not start from 0. It should start from some index after the middle. So I'm going to increment my start, or rather update my start to an index middle plus 1. I'm going to start searching from all indexes after the middle. End will remain as it is. Now I repeat from step 1. Let's see what our updated pointers look like. So we said that start should equal to middle plus 1, which is equal to 4 plus 1, which is equal to 5. End will remain as it is. Now we have defined start and end. The next step is to find the middle. 9 plus 5 divided by 2. This is equal to 14 divided by 2, which is equal to 7. 7 will be our middle element. Now we need to check where the element we are searching for will be placed with respect to the middle. Over here, the middle element is 50. So would I expect 25 to come to the left or the right of 50? I would expect 25 to come somewhere before 50 in the array. That is, I would expect 25 to appear to the left of 50. So what must I do? I must restrict my search to only the left of 50. So, if the element found at the middle is going to be greater than the element we are searching for, then search to the left of the middle element. So what does this mean? I want to search only to the left of the middle element. So my start will remain as it is. But my end is going to be updated to middle minus 1. As you can see, that gives us the range of all elements to the left of the middle within the confines of the start and end. So now that we have updated the start and end, let's see how the array looks like now with the updated pointers. So now we said that start remains as it is. End is going to come to middle minus 1, which is equal to 6. Now we search for, or rather we find the middle. So start plus end divided by 2 is equal to 5 plus 6 divided by 2 is equal to 11 divided by 2 is equal to 5.5. The floor value of 5.5 is 5. So now the middle is equal to 5. Now we need to see where the element we are searching for lies with respect to the middle. So the element at the middle is 25. The element we are searching for is 25. Would I expect 25 to come to the left or the right of 25? No, I would expect 25 to come at the position it currently is at. In other simpler words, we can say that the element in the middle is the element we are searching for. And so we have found our element which we are searching for at the index of the middle. So once we find that the middle element is going to be equal to the element we are searching for, of course, we can say that the element has been found. And then we have to return the index at which it was found. It was found at index middle. So we have these cases: first case, second case, third case. So this is when we are searching to the left, to the right of the middle element, to the left of the middle element, and finally when the middle element itself is the element, we have found the element and we can return. So now you see how binary search works when we search for an element which actually exists in the array. So we search for an element that is present in the array. But it can also be a case when we search for an element and that element is not present in the array. So let's take an example of a search when the element we are searching for is not going to be found. Let's say we are searching for 26. So now we have start and end defined. We are going to see the middle, which is going to be the fourth index, which is going to have 20. 26 is greater than 20, so we will search to the right of the middle index. So we will only search these elements. Now, the middle is going to be 7. The element at 7 is going to be 50. 26 is going to be less than 50, so we will search to the left of the middle index. Now we have the start and the end as 5 and 6. The middle is equal to 5. Element at the middle is 25. What are we searching for? We are searching for the element 26. The element we are searching for is going to be greater than the element at the middle. In such a case, what must we do? We must search all elements to the right of the middle. So let me just write that here. This is the variation where we are doing search for 26. It has the same first 3 steps. So now we are searching for 26. The middle is 25, so we want to search for all elements to the right of the middle. So let's see, when we wanted to search to the right of the middle, start is equal to mid plus 1, end will remain the same. So start was equal to middle plus 1. Start is going to equal to 6. End remains the same. End is equal to 6. So the middle, which is start plus end divided by 2, is going to be 6 plus 6 divided by 2, which is equal to 6. So now we see that there is only one element in our range of searching. Now we check whether the middle element is equal to the element we are searching for. 27, the middle element, is not equal to 26, the element we are searching for. And so, now we say that we have only one element left to search. And even that element is not equal to the element we are searching for. In such a case, we say that the element is not found in the array. So let's see what I have just said. I said that if there is only one element left to search, that is, if start is equal to end, this means one element left. So there is one element left to search. Even that last element is not equal to the element we are searching for. So even in this case, array of middle does not equal to the element. So when there is only one element left to search, and even that element is not equal to what we are searching for, we can say conclusively that the element is not found in the array. And then we return -1. So let's go over the steps of binary search. First we define start and end, then we find the middle, then we see where the element could be placed with respect to the middle. If it's greater than the middle element, it's going to come somewhere to the right of the middle. If it's less than the middle element, it's going to come somewhere to the left of the middle. If the element in the middle is equal to the element, we have found the element and we can stop searching. If we keep reducing our range of search, finally we come to only one element, and even that element is not equal to what we are searching for, then we can say that the element is not found in the array. This is how the binary search algorithm works.